Welcome back, dear students. So let's start with, or rather let's continue with exercise 1b. Today I am taking question number 13, where you have to write the following in ascending order. Now there are questions on descending orders. You will try them by yourself. Okay, so without wasting much time, let's start the first question. Okay, so first question says it is 3 root 5 is one of the number. Okay, so be very careful here. Okay, now this is square root, isn't it? So whenever you take any number within square root, you have to write, suppose this 3 is there, so when it goes within square root sign, you have to write 3 square. Okay, and what is the other number here? We have 5, so we have to write into 5. What is 3 square? 3 square is 9, isn't it? So we have 9 into 5. Okay, now 9 5s are, how much is that? Isn't it 45? Yes. Okay, so similarly we have the other number. Let's see how much is that in the same manner. So we have 4 root 3. Now bring this 4 within square root, it becomes 4 square. Okay, into we have the number to be 3 here, isn't it? Okay, so what is 4 square? 4 square is 16, right? Into we have 3. Okay, so 16 into 3 is how much? It is 48. So that means this is nothing but root over 48. Now, which one is bigger? This one is this one or this one? Obviously 48 is bigger, isn't it? So that's why in ascending order, if you want to write this in ascending order, we will first write the smaller number, that is root over 45. So root 45 is less than, we have root 48. Okay, now you know this root 45 is nothing but 3 root 5. So 3 root 5 is less than root 48 is how much? It is 4 root 3. So this is my ascending order for this particular question. Now let me take number 2 for you. Okay, so in number 2, in question number 2, the first number is, so question number 2, first number is 2 cube root of 5. Now this time we don't have square root. Okay, so when we had square root here and when we took this within square root, it became 3 square, isn't it? But in case of cube root, this is cube root, right? So when it goes within cube root, you have to write 2 cube. Okay, so we have 2 cube into the other number is 5, isn't it? Okay, so 2 cube means 2 into 2 into 2 is 8. So 8 into 5 is how much? I'm sorry, we have to write cube root here. Okay, so this is your cube root. So this becomes cube root of 8 5s are 40. Okay, so we got our first number. So let's see the other number. The other number is 3 cube root of how much? 2, right? Now when this 3 goes within cube root, I told you it becomes 3 cube. 3 goes inside, becomes 3 cube, and we have into 2 here. Okay, so we have cube root of 3 cube is 3 into 3 into 3, which is 27, into we have 2. So tell me, what is 27 into 2? This is 54. Now which one is bigger? Obviously this is bigger, so therefore we write, therefore we have cube root of 40 is less than cube root of 54. Okay, now you know this cube root of 40 is nothing but this much, isn't it? So we are writing 2 cube root of 5 is less than, now this is nothing but this much, so we have 3 cube root of 2. Okay, so this is my ascending order for you. Okay, so you may pause the video and note down your solution. So next we have compare. So this is also similar kind of problem. Let me do only one sum from here. Okay, so let me take number 1. Okay, so number 1 says the first number is this time 6th root. So this is 6th root of 15. Okay, now 6th root of 15 is how much? This is, see here carefully, this is 15 to the power 1 by 6, because you know the formula says m root of a is a to the power 1 by m. This is the formula that you have learned from your indices chapter. So that's what I have done here. Okay, similarly, let's see how much is this. So we have 4, this is 4th root of 12. Okay, so can I write this as 12 to the power 1 by 4? Yes. Now, how to compare such kind of things? Here, what you need to do is, here you need to make the denominators of the power to be same. Okay, so that can be done by multiplying with, see here carefully, I am multiplying the power with, okay, so we have to see, we have 6 here, we have 4. Okay, now can I multiply this by 3? Okay, so can I multiply with not 3, can I multiply with 2 by 2? Can I do that? Yes, because 2 and 2 gets cancelled and ultimately I'll get the same thing. Okay, so here also I'll do, okay, so when you multiply with 2 you get 12, isn't it, in the denominator. Now to make denominator 12 I have to multiply here by 3 by 3. Okay, now let's see how much is this going to be. So this is going to be 15 to the power, so 2 by 12, isn't it, and this is going to be 12 to the power 3 by 12. Okay, now there's one more law from laws of indices which says a to the power m whole to the power n is a to the power m n, isn't it? So let me apply this law here. So can I write this as 15, so power in the numerator is squared, so 15 squared into to the power 1 by 12. Can I do that? I'm applying this law. Okay, so when you multiply 2 and 12 you get 2 into 1 is 2 by 12. That's what is there in the power. So same thing I'm going to do here as well. Okay, so it is 12 to the power 3 whole to the power 1 by 12. Okay, is that clear? Okay, now we have, so let's see, we have 15 squared here. 15 squared is 225 to the power we have 1 by 12, isn't it? Now we have 12 cube, right? So 12 cube is, so 12 cube is 12 into 12 into 12, right? 12 into 12 into 12. So 12 into 12 is 144. We have 12. So 12 fours are 48 carried over 4. Again 12 fours are 48, right? So we have 52. So let me write 2 here. So we have carried over 5. 12 ones are 12 plus 5 is 17. So we get, this is 12 cube is 1728. So this becomes 1728 whole to the power 1 by 12. Now here also power is 1 by 12. Here also power is 1 by 12. So the base is 225 here and the base here is 1728. Now which one is more? Obviously this one is more, isn't it? So that's why at last we have to write, so we have to write that 225 to the power 1 by 12 is less than 1728 to the power 1 by 12, which means, now how much is this actually? This is nothing but 6th root of 15, isn't it? So we have 6th root of 15 is less than, how much is this? This is 4th root of 12. Okay, so we have 4th root of 12. Okay, so this is how we do this kind of sum. Okay, so you may pause the video and note down your solution. So we have another question. Let me jump directly to question number 6. Very important question. So there are two techniques for solving this kind of sum. Okay, so one is called very famous contradiction method. Okay, but For now, I will not use contradiction method because it's going to be a bit tough for you. It's going to be new concept for you. Okay, so let's not waste time in that. So let's use the concept that we have learned in our class 8, that is finding the square root using division method. So let me take the first one. So we have, first one is, so root 3. Okay, so let's find, we have root 3 plus root 2, right? So first let's find root 3 and let's find root 2. Okay, so I'll show that root 3 is non-terminating and non-recurring. Similarly, I'll show you that root 2 is non-recurring, non-terminating. Okay, so this non-recurring, non-terminating plus non-recurring plus non-terminating will result in non-recurring and non-terminating, which will also be irrational. Okay, so let's find root 3. Okay, so root 3, to find root 3 by division, we will write first this pair. Okay, so I hope you have watched my video on how to find square root using division method. Okay, so it continues this way. Okay, so we have to divide this, right? Okay, now, okay, so if you have watched that video, so first we have to start with 1. Okay, so we will write 1 into 1 is 1. Okay, you will add this number to this. Okay, so let me add 1 to this, you get 2 here. Okay, here you need to subtract, you get 2. 3 minus 1 is 2. Now there is decimal, so we'll put decimal out here. Okay, so these two will come down. Okay, so you get 200. Now you have to write a number here, and the same number has to be written here. Okay, so we'll write 7 here. Okay, so why not 6? You can check that also. Okay, so 7 sevens is 49, carried over 4, 7 2 is 14, plus 4 is 18. Okay, so isn't this less than 200? Yes, that means if you write 8 here and 8 here, you will get a number greater than 200, which cannot be done. So 7 is written here, so you need to write 7 here and need to add with 27. You get 34. Okay, now when you subtract here, you get 11, isn't it? Okay, so bring this down, so you get 1100. Okay, fine. Now we have to write a number here, so let me write the number to be 3. Okay, so if I write 3 here, I have to write 3 here also. So 3 into 343 will be 1029. Okay, so when you subtract, you get 71. Bring this down, so you get 00 out here. Okay, so you need to add 3 here, remember. Okay, so we get 346. Okay, now you have to, okay, so let me extend this line, so you have to write 2 here. Okay, so if you write 2 here, then it becomes 6924. Okay, so when you subtract, you get 196. So basically you get this 00 here, and it keep on continuing. Okay, so when you write other numbers, you get here the other numbers to be 0, 5, 0, and it continues. Okay, all right, now I founded root 3, so this is the value of root 3. Okay, so therefore root 3 is how much? Root 3 is 1.732050, and it continues. So this is the value of root 3, which is irrational, right? Okay, now similarly let me take, or let me find root over 2. Okay, so let me find root 2 for you. So for finding root 2, again I need to do the same thing. So 2.00000000, it continues. Okay, so there is a decimal out here. Okay, so in the same way, okay, so here again you need to write 1. So 1 into 1 is 1, add 1 to it, so you get 2 here. So this is 1, get, okay, so we have decimal, so decimal is there, so bring this 2 zeros out here, so you get 100. Okay, now you have to write 4 here, because 4 into 24 becomes 96. So we will add 4 here, you get 28. So when you subtract this, you get 4. Bring these two. Okay, so first form the pair. Okay, so bring these 2 zeros, so you get 00 out here, so 400. So you have to write 1 here, so 1 into 1 is 281. Okay, so add 1 to it. All right, so this becomes 282. So when you subtract this, you get 119. Okay, so bring this 2 zeros, so you get this much. Okay, now how much should I put here? Should I put 4? So if I put 4 here, I need to put 4 here. Okay, so when you do that, the 4 into 2824. Okay, so it's going to be 11296. You can verify. Okay, 4 into 4 16, carry over 1, 4 into 2 8 plus 1 9. Okay, so you can verify. Now 4 is there, so we will add 4 to it. Okay, so let's add. So when you add it, you get 2828. Okay, so when you subtract, you get 3836. So bring these 2 zeros down, so it becomes 00. Okay, and you have to write it 1 times. Okay, all right. I'm sorry, there's a mistake out here. Just wait a minute. Yeah, okay, so yes, it's okay. So if you do in this way, yes, you get this much. So therefore we see that here root 2 is how much? It is 1.4141, and it continues. Okay, so therefore see, this is also irrational, this is also irrational, right? So therefore we clearly say that root 3 plus root 2 is non-recurring and non-terminating, right? So therefore root 3 plus root 2 is irrational. So this is how we need to do. Now in this case, root 2 is there, so I have found what is root 2. Okay, similarly from this you find root 5. Okay, now you know the difference of rational and irrational will be irrational, right? Same thing happens here, so that's why you have to do the same way in this problem. Okay, so you may pause the video and note down your solution. With this we close for the day. Thank you very much.